we
How are
are.
you doing today, Angela?
I'm doing fantastic. I'm coming off a really good day so far, and it's only getting better because I'm going out to dinner after this.
Okay, chow time. That's what I'm talking about. And it's Tech Tuesday.
Hello, you know we celebrate here at From Cover to Code. We celebrate every Tuesday, every Tech Tuesday,
Yep.
with more tech goodness. And today is the culmination of the book we've been reading, Programming AWS Lambda, aka I'm a Java book. And we are wrapping it up in a nice little bow. We're going to talk about the what conclusions the book has made. There is a new section, chapter 9, talking about serverless architecture. So there's a
Hmm.
lot to think about. We have a lot to talk about today, and let's get into it.
No doubt. Let's jump right into Chapter 9, Advanced Service Architecture. I mean, they started off talking about the gotchas.
Yeah.
And I thought it was kind of interesting that they talked about this concept of at least once delivery. So with Lambda, when a Lambda function executes, you're going to get it at least one time.
At least once,
But
maybe
you know,
more,
you
depending
might get
on
it.
what's happening before we get to the function. So, yes, that was a teachable moment for me. That
Mhm,
term, at least once delivery, it
mhm,
doesn't say how many times you're going to get it, but you
mhm.
can guarantee you're going to get it.
Yeah. So you're going to get it. And the crazy part is you have to, as an architect, if you're considering Lambda for a very
Yeah.
crucial system or whatever, have to consider that, yeah, you're going to get it at least once, but you might get it twice. And I think they
Yes.
said like maybe 1% of the time your function might be executed twice. So if it's a critical thing, like the example that they gave was calculating interest on a
Yes.
bank account or something like that, or charging somebody,
You can't be
you want to
double
charge them
dipping.
twice, you know. So yeah, that you have to consider that type of stuff.
Right. And the alternative or the opposite is if it's like, well, it's okay if
Hmm.
the function runs twice because it's literally only sending out a message or it's sending out
Hmm.
an SMS or it's sending out an email. No one will die. No one
Hmm.
will get, double dipped if you ran said function twice. But it is something to consider. And
Yeah.
there was also a little caveat in there about it being something called a request ID. And
Hmm.
if you have an application that is very sensitive to that, you could probably tie in DynamoDB or some sort of place to have some state where it keeps track of said request
Hmm.
ID. And if it's there, don't do it. Don't run
Yeah.
again. If it's not there, you can go ahead and insert an update, and it knows it's okay to proceed with the function. But that was interesting. So again, it depends on the criticality of your
Yeah.
application and what it can stand, right? So your mileage may vary depending on what your application is.
Yeah. And that just kind of makes me think about sidebar. But since we're talking about architecture, I took an architecture training maybe about a month ago, and one of the things that they mentioned was like the difference between engineering and architecture. And now I'm trying to figure out which one was applied to which.
Oh,
But I think architecture is building the right thing, and engineering is building the thing right. Right.
oh,
So
I
you
love that phrasing.
I know. I was like, wow, mind blown, right? Because you don't want to over engineer solutions that don't require it, and you don't want to over architect solutions that require it. So in this case, multiple executions of a function, like you said, if it's an email, yeah, they can get it twice. Let's not worry about it, But if it's like checking medication or like somebody messing with somebody's money or something like that, let's put a little bit of something extra in here, from the architecture standpoint and from the engineering standpoint, to make sure that we're building the right thing and we're building the thing right.
Oh my gosh, we need that. That quote needs to be somewhere. Like I
Yeah,
don't know
t-shirt,
where,
something.
but
Yeah.
it is very poignant. And when you think about it, that's just exactly what architecting and engineering. If when you think about it, when you think about when
Hmm.
people are engineering a solution, you want to make sure they're doing it right, right? So
Hmm.
that
Yeah,
I
exactly.
yeah, we gotta Repeat that
Yeah.
again, please.
Build the right thing and build the thing right.
I love it. Okay. Total aside, since we're talking about AWS, I'm just gonna
Yeah,
drop
no doubt.
I'm gonna drop this little gem in there because there was a section where they were talking about running cron jobs
Yes.
using
Yep.
Lambda. And I was like, oh, okay, this is what we know. We know how to do this. And you can use the CloudWatch scheduler, scheduled event as a trigger for,
Hmm.
and you can use SAM to write a trigger function and use cron syntax, right? So the stuff that, engineers or admins or whatever, we're kind of used to that, right? But I found out something recently, like writing a cron job. I had to move it from AL2 to AL 2023.
Hmm.
And Cronny is no longer installed in AL
Yeah.
2023. And
Yeah.
it's, they're recommending that you move to system D timers. And this was my first time in production writing one. You do it like when you're learning the what is it, Red Hat RHCSA, I think you may
Mhm.
write timers or some sort of unit file. But yeah, I look at me, I'm nervous, but now I learned something new, so I'm fine with not because you know what, that's what AWS does. If they
Yeah.
say, all right, now we're not installing this, at some point it will not be in a later version.
Yeah.
So prepare yourself with system D timers.
No
It's
doubt.
when
Or just pull those
Lambda.
scheduled functions into a Lambda
There you go.
and use a scheduled event. I did include a demo for a Python scheduled event. I'm not going to demonstrate it. If you want to find it yourself, dear watcher or listener, you
Yes.
can look in our GitHub, github.com/cover the code/season 2 programming AWS Lambda. All the code is in there. There's a Python function that demonstrates scheduled events. And I've
Awesome.
got some other functions that I will get into later on in this discussion.
Okay. You have my full attention because now that I've learned something new and I'm implementing it, I will figure out and learn how to write a function based off a CloudWatch scheduled event
Yeah,
and making it a cron job. So who knows? This is why we do this. This is why I do this. Like,
I know. I
I want to
know.
learn new stuff. I want to stay engaged. I want to just, it's what I do. So I'm glad you put that out there. I may learn a thing
Cool.
or two and maybe refactor something, not in
Hey,
production, because I think what works now works. Like you said,
yeah,
don't over engineer. Doesn't need all
exactly.
that. But who knows? Want to
Yeah.
grow on. So anyway,
Yeah. Moving on.
moving on. Quick, that was that was not a quick aside, but
I know.
let's see. Least once delivery, we got that.
Yeah. And
Talked
that,
about the
yeah,
new,
tied into item potency
yeah,
with the DynamoDB to track request IDs
yes.
and living with the consequence of multiple calls. We can, yeah, understand that.
Okay. Next is what? The impact.
Well,
We know Lambda scales because that's
yes.
one of the, the money shots, right? That's the feature. Its ability to scale and handle the events that are coming its way. But if you are feeding said
Yeah.
info to a downstream system, it needs to be able to handle that scale that's happening at the Lambda end. You know, if you're throwing too many balls at one time, you're not going to be able to catch them all. So there has to be a
Hmm.
strategy in place how to mitigate that. Like, how do you deal with, a whole lot of traffic? Your downstream systems could be a NoSQL database, what, that's just an example, but how do you handle the impacts of Lambda scaling?
Yeah, indeed. Because I mean, last week we demonstrated how to or how a function can scale out, and
Mhm.
it creates multiple copies of your function and runs them concurrently. And then, so to your point, if you're thinking about these systems, these functions receiving these requests, Lambda's doing its thing. It's scaling out. It's taking care of business. But that system that's depending on Lambda is like, hey, hold up, wait, I can't handle traffic that
Slow
fast.
down.
Yeah, so you got to bring in something like a queue. So Lambda sends its results to a queue that holds that information, holds that data, and then the downstream system can pick up the data off the queue and process it as fast as it can, so that way. And I think they talked about these hybrid solutions that include DynamoDB and databases, so you have some sort of a store, some sort of in between this totally scaled out Lambda and maybe a slower system downstream that can handle all these requests.
Good stuff. So yeah, deliberately hybrid versus accidentally hybrid.
Yep.
Again, being very understanding your application and what it can handle, using like scaling infrastructure. Like if you're going to be using this serverless function platform, why not tie it into like scaling infrastructures? And they use the example of like DynamoDB or SNS. It is built to take some of that and be able to deal with the scaling of Lambda. There was another one about scaling upstream and restrict the number of events that can be triggered, that can trigger the execution. So that's putting like rate limits, or not rate limits, but I'm liking it to rate limits. And then it harkens back to chapter 8 when it was talking about reserved concurrency. And that is another way to kind of make it slow its roll a little bit. You want to talk a little bit about that?
Well, yeah, I mean, reserved concurrency, you're going to, well, no, you know what? I'm thinking of, what am I thinking of? The other one.
There is another one and it didn't pop into my head.
Yeah.
It didn't.
So maybe I'm drawing a blank on it with it's not like keeping your functions hot and running.
Not cold starts or whatever.
Yeah. Okay. No, reserved concurrency where they, and I'm drawing a blank on it now. Okay. Maybe I have to flip back to chapter 8.
Let's see. You're still thinking?
I'm processing. The wheels are spinning. Provision concurrency. Yes, okay. Provision concurrency. So they do keep some of your functions hot, ready to run, but you're paying for the cost of keeping those functions running. So there's trade-offs both ways. And the other thing, and I think I didn't look too closely at because again, it was Java. I didn't look too closely at this example, but it made me think about API gateways, and you can also put rate limits on API gateway.
Yes.
You can, if you want to like sort of throttle things there, you could also use that approach.
Yep. And
I was just going to say, and that's where the architecture comes in too. You got to think about the cost of all these things as well. Provision concurrency to handle a whole bunch of requests, API gateway to slow down people, hey, you can only make, 1,000 requests per day or something like that,
right.
Or even people, systems, whatever's calling your service or your function. Different ways to architect it for sure.
And there's one little caveat with reserved concurrency. That means it'll scale out just as much as you tell it to. So you're setting a limit on how much the functions will scale out. It means if you set 10, your function you can only have at most 10. But the caveat is that capacity is shared across the account, across all functions. So if some of those numbers aren't monitored and people are setting this reserved concurrency, you might run into not having enough capacity to run your Lambda function. So your mileage may vary, but because that number is shared across the account, and if you're running a myriad of functions and you're using this as a way to help manage your downstream when you're scaling up here in the function, just be mindful of that.
Yeah, no doubt. Cool.
Look at us.
And then, moving on, they go into new patterns of architecture enabled by serverless thinkings. I had a few notes on this.
Oh, please.
Particularly where they talk about globally distributed applications. Well, even before that, I'm trying to think. I'm just looking at my notes here. They said serverless component registry for SAM CLI, where you can create components that you can use across your functions. I guess if you're a SAM CLI shop, and you're getting more mature with the applications that you're developing, you're probably going to see those patterns where you're developing the same things over and over again. So that is a way the component registry is a way to reuse things that you've already developed. They're battle hardened, they've been tested, they've been scaled up, scaled down, and everything is working fine. So you want to reuse that code instead of building it from scratch each time you roll something out.
Yes. So serverless application repository is just like having a repo of your code inside your organization, where people don't have to reinvent the wheel. But the cool thing about this package, this group of components, it is an infrastructure and an application and a service, like all bundled in. So you can have gateways, you can have functions, you can have databases, and all grouped into one unit. And the beauty of that is you can reuse this over and over between accounts and throughout your organization. You can also put them inside of bigger applications and use them as a small piece of a much bigger system. And the fact that you can reuse your SAM apps via this repository, where you can publish your app, you can deploy it there multiple times, different regions, IAM withstanding. I thought that was cool. Did you take a look at the repository to see what kind of goodness was in there?
I did not.
No. You know what?
I should have. I mean, I was too quick to get to the command line myself to just start creating I was reading this and reading on. I got excited about the next section, we'll get to in a second. And I just started coding right away. I didn't even go to the registry itself.
That's okay. I was just window shopping to see what was in there. And then you can look in the repo and see some are very well documented, but and then some are like, okay, I don't even know what's here. So it's just like when you're going to GitHub and you're, looking for something new, and it's like, okay, there's nothing in the README. Dang it. Right. Okay. Well, let's keep looking. I
know.
Yep. So we talked about the nesting components. There is a downside. They said you can't use all of the CloudFormation resources in it, like EC2 instances in a repository. So again, you find the right tool for the right job. There are other ways you could probably tie in those resources that aren't allowed in there via scripting or some sort of automation, but it's not a one-stop shop. But it seems pretty interesting.
Yeah, and I think, like I said, a mature team working with this would probably figure out a way to have Terraform or CloudFormation generate whatever it is missing, and then grab the outputs from that stack and pull it in to their SAM stack. So,
All right. Serverless thinking. They've coined an interesting phrase here. Serverless.
Yeah, I thought that was kind of cool. I mean, it does take it to another I would say another level, but a different way of thinking. It's already like in this day and age, you have to think of distributed systems and data intensive systems. And if you're still, I shouldn't say still, but you're approaching it in a serverful, for lack of a better term, approach, then you have to think, then you have to think about the service, right? But if you're thinking about it in a serverless way, then you have to take some of these things into account. Like we've mentioned, the at least once delivery, idempotency of your function, concurrency and downstream, and the cost related. And also it's a different sort of a mindset. And you also have to think about global distribution, which, I mean, if you don't mind if I segue.
Please, this is the perfect segue.
Yeah, to the next one. If you're thinking about applications that are running globally across the world, of course, AWS has data centers everywhere. You want to keep in mind you can minimize latency by having your clients connect to regions that are closer to them, and also minimize your risk of an outage, a regional outage, by distributing your workload around the world. So some of the things they talked about were like global deployments. I think they talked about geolocation to point to the Lambda instance that's closer to you. Some of those could be kind of funky if you have to hard code the URL, the application URL, or the function, whatever, into your application. That could be kind of funky. They talked about health checks and DNS failovers, which might be a
Mhm.
better way to handle that. And then they talked about global state. I'll
Yes.
pause there because I've been rambling. If you had any
No,
thoughts on it,
no. Your
because
your comments are mirroring the notes that I had. So take it
okay,
away. Take it
all
away.
right, all right, because I love my demos.
I love your demos too.
Right. So this was the section, the chapter that really called to me. So like I said, I didn't even look at the other thing. I just jumped right into the code, and I was like, oh, this is kind of slick. Maybe I can pull together a demo for this.
Yeah.
So if you're listening, I'm looking at figure 9.5, which is a diagram that shows multiple regions with a replicated database.
Yes.
So it's got 3 regions. Each one has an API gateway fronting a Lambda function, and these Lambda functions are connected to DynamoDB tables. The interesting thing about it is these tables are in the same region as the function. But if you write to the table, if anything writes to this table, it's going to be replicated to the other regions. So, I mean, it helps minimize latency in the region that you're in. And if that region goes away for any particular reason, then you have copies of the data in these other 2 regions that you can pull from. These other 2 functions will keep running and be fine. It would be different if the data was in a single region and that region went away. You would have trouble. You would have problems. So go ahead.
I was just going to say that this is a great way to bake in availability using a
Yes.
service, using an AWS service that has this type of redundancy built in, where it doesn't matter which region your systems are or where your customers are, you'll be able to read and write easily because all that data is replicated. Hopefully pretty quickly, which I'm going to assume because it's DynamoDB and it's doing it synchronously across all 3 regions. Yeah.
So in my demo, I didn't mirror this directly, but I didn't have the time to make a graph for it, but I deployed to 4 regions. I have a writer in one region,
Okay.
US East 1, that's going to write to the table, and then I have readers in US East 2, US West 1, and US West 2 that are reading from the table. And I mean, they could write to it if I configure the application to do that way, but just for this example, that's the way that I have it set up.
Okay, all right.
So here's my table, and I did use SAM CLI even to deploy this. I mean, I was like, wow,
Beautiful.
this is one of the things that SAM is good for. The exercise that they posed, the authors, at the end of the chapter was to use CloudFormation for this. But I was like, I'm sitting here with SAM CLI, right here in the thing. I was like, why should I go to CloudFormation when CloudFormation and SAM, they're pretty much the same thing. So again, I lean on AI, and I was like, my friend AI, can you generate a template that deploys a global DynamoDB table using SAM CLI? And it was like, yes, sir, of course I can. Here is a template that you can use. So I use that to deploy the template in its own stack. So this is separate from all the functions and everything.
Gotcha.
So that's the table in these 4 regions. And then I deployed, I guess this is showing the reader. I deployed the writer function in US East 1. And I deployed readers, like I said, in East 2, West 1, and West 2. Mm-hmm. And they all look like this as I'm showing on the screen. I've got a global table reader. We're looking at US East 2. And in each of these regions, this was kind of a gotcha for me. I had to set up a SAM CLI managed default stack, excuse me, in each region before I could deploy. Because all this season, I've been working in US West 2.
Yes.
So then I tried to deploy to US East 1, and SAM CLI was like, hey, I don't know what's going on here. Like, I don't even have any sort of reference to how to work in this region. So I had to do some research on that. And I was like, oh, I need to set up the SAM CLI managed default stack in this region so I can start deploying stuff. So I had to do that for East 1, region? East 2, and West 1. Yes. I had to do that across the board.
And that is very similar to having global deployments. This is basically what you're doing, where you have to define your application templates in a region neutral way, which is very complex to do. And if you're using SAM deploy, you'll need to have all your artifacts somewhere in that region, just like
Mm-hmm.
you learned. So doing global deployments, yes, it's great for availability, but there is a complexity that is involved with it and a cost, of course.
Yeah.
But yeah.
Yeah, and I'll show the banner again. The banner for the repo. All this code is in github.com/cover the code/season2 programming AWS Lambda. And I'm sharing that because, yes, I had to write deployment scripts. The build script was easy because I only had to do 2 builds, once for the writer and once for the reader, because the reader code could be deployed across all these regions. So I only had to build the reader once, but I had to deploy it 3 times separately. Because those resources, like you said, had to be in that region.
That's right.
For the Lambda to be able to be deployed. But once I got everything into place, I was able to write. So this is I'm showing the output from my writer function. It's a simple call, and really the architecture is simple. I didn't do anything crazy. You just curl the URL to the function, and it just writes its event and context to the DynamoDB table. The readers just read it back. You don't have to pass any parameters or anything. So this is the output from the writer. It just says, hey, I wrote this data to the global table. Done. It also says it's in US East 1. So then going to the reader output, and I did this for each one, but we're looking at the output for the US East 2 writer. It pulls the data from the table, and really there's only one entry. I just use the same entry over and over every time. And it says, hey, who wrote this data? Well, it's the global table writer. That's the name of the function that wrote it. And where was it written from? It was written from US East 1. And so then from the reader, it reports where it read the data back from and the name of the function that read the data back. So that way I'm able to tell, through all the output, which reader is active, where the writer was coming from, and all that kind of stuff. So this was just a very quickly pulled together example of how to use this this globally distributed data and functions in each region to minimize latency, preserve state. Maybe you could use it for idempotency and all these other things that they talked about in this serverless way of thinking.
Serverless way of thinking. Yes.
Yeah.
This is a great example of what this chapter is about in a nutshell. Rethinking, reimagining your architecture to make your system available to wherever your user base is, reducing latency and doing it in a smart way. Don't over architect, don't over architect, and the simplicity of what you just showed. Depending on what your use case is, this might be just what you need. But again, your mileage may vary, and different use cases require different tools. So what next? That was a great demo though. And thanks for sharing that. Is there anything else? The only other thing that I kind of leaned into in this one, and really it's just for comment, where they talked about edge computing or regionless computing using CloudFront. And CloudFront is a CDN content delivery network, and they have this concept of Lambda at the edge, where, first of all, CloudFront is widely distributed. Like CloudFront could be in a data center right down the street from your house, because they want these edge endpoints to be as close to the clients as possible. So the data center could be in Virginia somewhere, and say you are in Washington, D.C., well, you've got this endpoint that's closer to you in D.C. than that data center in Richmond or wherever. But these Lambda at edge functions can only work with CloudFront. They can't be used in other means. So they're HTTP only. And they say at the time of the writing, they can only be written in Node or Python. I didn't check to see if that's changed. I didn't check
Java
either. I didn't check either.
Or anything like that. But I thought that was interesting. They do have more restrictions on the memory and the CPU that you can use, and the timeouts are different. So, but the use of Lambda at edge is, if you have something, the first thing that I thought of was number one, streaming video. If you want to do some manipulation to, the responses that you're giving to somebody on their mobile phone, video games. You know, you want your game time, gameplay reaction to be super quick. Yeah. And if you're playing like a globally distributed game, maybe there's some little bitty piece of state that you can cache at the edge, and this little function can manipulate it so that the response to the client's mobile phone or their computer, whatever, is super quick. You know, that's just a couple examples that I thought of.
I think the number of languages that Lambda at the Edge supports has gone up since since the writing of this. So I'm trying to see on the AWS website exactly what those languages are. But of course, when you Google, it returns to you the languages. I always have to go back and check the source to be 100% sure if those languages actually supported, those runtimes are actually supported at Lambda at the Edge. But make sure you go out there and check. But I think that's pretty cool. There are at this time over 400 points of presence. So when we're talking about a global infrastructure and having that CDN in that could be in a data center across the street or across the city or across the world, depending on where your customers are, AWS has really grown their footprint for CloudFront.
Yes, indeed.
Indeed.
And that wrapped up the chapter 9, and they went into a very, very short conclusion of chapter 10. A couple highlights from the previous chapters. I don't really have anything to call out from the summary. I mean, it kind of is what it is, you know. And I was thinking, and maybe this is definitely spur of the moment for me as I reflect on this. Like, do you, Angela, have any lessons learned? And I'll think of maybe a couple lessons learned to share. I don't know, just to kind of wrap things up.
No big takeaways, I guess, because we have been traveling along this road together, and every week it unveils new functionality and a new way of thinking for me specifically. And let's see. There's a term I'm going to say earlier in the chapter where they were talking about event driven, and that was all the buzzword a couple of years ago, because if something is event driven, an event in your environment will trigger something to happen, and something happens. And I never thought of being able to use Lambda in this way. Now, I know it's event driven. It can have multiple event sources, but depending on how you're writing your functions, you can have those functions do a myriad of things in your infrastructure, in your architecture. So that's not a real takeaway, but I thought of event driven in this very narrow box. And then we get to this chapter in this book, and it's literally the foundation. Events trigger Lambda. So I guess it was almost like an aha moment for me. And there were a lot of gems, but a lot of learning happened for me in this chapter. So what can you say?
Yeah, well, for me, I mean, I did learn a lot about Lambda. I was already very familiar with Lambda. A lot of my interaction with Lambda was from the command line and or using the AWS CLI and or Terraform. And usually the way that I work is I'll build out the Lambda infrastructure using Terraform, and then I'll deploy these functions using the AWS CLI. So
now look
SAM
at you,
CLI.
Sam. Now look at you.
Out to Sam. I feel like I'm SAM CLI proficient now.
You are. I think you are.
Yeah, I think if I ever come across the opportunity to work with Lambda functions again, I will reach for SAM CLI first. I don't think I would go from scratch with Terraform AWS CLI. The one thing
takeaway. That's a huge. You've just reimagined the way how your workflow can be using what you learned out of this book. That's awesome. That's huge.
Yeah. And the one thing that really kind of got me there was in the past, like I would write very pure Python functions. And by pure, I mean no external dependencies.
Gotcha.
Everything, like I'm using the base built-in Python libraries, because bundling and deploying a Python function with dependencies from the command line it's not impossible, but I've never grokked the whole thing, right? It's just like it never really came to me. So I just like, you know what? I'm not going to worry about it. I'll just do the pure Python stuff. But seeing how SAM does it, where I can have my requirements.txt with my dependencies, SAM build, it bundles it all together, SAM deploy, it puts it in place. I'm like, you know what? What have I been doing?
It's a super tool. It is a super tool. Yes, that was another good tip out of this book. I'd never heard of it. I'd never used it, and seeing how it works and how it makes deploying to AWS so seamless. And it has so many built-in plugins that you can do just about anything, not with EC2, of course. But yes, you can really do a lot. It builds out your infrastructure, everything. So if we didn't learn anything from this book, it was how amazing the SAM tool could be.
Indeed. And I know we got to land this plane. I still want to chop it up with you for a little bit while we got some time.
Yeah.
What is next from Cover to Code? Because if you're joining us just now, dear listener or watcher, this is the last episode of season 2. And so we're making plans for a break, and we're making plans to come back bigger, better, faster, stronger for season 3. So, what's next for you, Angela?
Oh, well, next week I will be, our break starts today. Next week, I will be giving a talk at Red Hat Summit with my Red Hat BFF on RHEL image mode next Wednesday. I will probably try to squeeze in the AWS certified AI practitioner exam after this talk, and then I need to buckle down on the SysOps exam for AWS. So we're taking a break, but we're taking not a real break. So you may see us during the summer talking AWS. I might need your moral support to get through this and get this exam landed. I want to be done by the beginning of Q3. Summer,
that's a
I'm
target.
Focused. I'm gonna need all y'all help to get through this, and then I have to take the solution architect, and because it's expiring at the end of the year, so no pressure. But I'll be busy, and you, my friend, your dance card is mad full.
I am going to be crazy busy this summer. I'm updating not 1, not 3, but 6 courses for LinkedIn Learning. So look for updates if you happen to be following me on this podcast as a student or a learner that has taken Learning Jenkins, Learning GitHub Actions for CI/CD, running Jenkins on AWS, Essential Jenkins, and what's the last one? I can't remember the last one.
And it's so funny, your last name is what?
Jenkins. Right. Yeah. So I will be working on those 6 courses, and I'm also, God bless my calendar if I can make it happen. I'm going to come back for CI/CD Summer School, which I started last summer, 2024. So season 2, and it's an annual series, right?
Yes.
But season 2 of CI/CD Summer School, I don't know, July, August, maybe.
I can't wait.
How the calendar lines up.
I can't wait.
Yeah. So
you'll see us.
Yeah, once I get that lined up, I'll invite you to my live streams, and once you get your thing set up, invite me to your live streams, and we'll come back in the fall with season 3 of From Cover to Code and talk all about it.
Let's do it. Well, thank you so much for rocking with us. We just completed programming AWS Lambda. We just landed that one. It's AKA I'm a Java book. And we're looking for suggestions for next season. I've seen some suggestions come our way. We are still open. We're going to spin the wheel. It will have to be a book that has been written in the past 24 months. So we're going to make sure that
Yeah,
we
make sure we got something current. Yeah.
very current, very very functional, and we want it to be something that we'll all have a takeaway from. So make sure you hit us up on our socials using the hashtag cover the code. Let us know what you thought about this season, what book you'd like us to cover next, and we would definitely like some of you to join us. Like if you're really along for this ride, if you're riding with us, then we'd love to hear it. We'd love to talk to you.
No doubt. So with that, I think we have reached the end of this season, the end of this episode.
Yes.
And we'll see you soon.
We'll see you soon. Take care, everybody.
All right. Bye.